Now we're going to look at one of our intensive intervention tutors, Stephen, and he's working with Natalia. And we're going to see clips of 3 separate videos that are all one lesson related to fraction computation. And here Stephen is teaching addition of fractions with unlike denominators, which is one of the more complicated computational skills that students have to learn when it comes to rational numbers. So in this first part, we're going to, when thinking about explicit instruction, this is really heavily, on the modeling side. So Stephen is modeling how to solve an addition problem with unlike denominators. We're going to use representations a little bit in this. Actually, we're going to use them a lot. I'm sorry, I kind of forgot exactly what we're doing here. We're going to use multiple representations. We're going to draw the different multiples. He's also going to get out the 2-color counters to show fractions. And then I want you to see how Stephen is precise with his language. So how does he describe denominators and numerators? How does he describe multiples? Those are all important things to pay attention there. So let's watch this first part, and then I'll come back and introduce the next 2 videos.
Alright, Natalia, today we're going to work on adding fractions, okay?
Okay.
Alright, so can you give me an example of 2 fractions that have the same denominator?
2/5 and 4/5.
2/5 and 4/5, good. So when we add fractions with the same denominator, it's pretty easy, right? I mean, you just add the numerator, kind of like these right here. So in this first problem, we have 3/7 and 2/7. So if we wanted to add these, we would just add which number, the denominator or the numerator?
Numerator.
Numerator, good. So what is 3 plus 2?
5.
5. So we would write 5. And then what do we do with the 7s right there?
We keep them the same.
Keep them the same. So our denominator in the answer would be
5/7.
7 would be the denominator, and our answer would be 5/7. Good job. So when we have fractions that have different denominators, it's a little trickier, okay? So we have a sheet here that gives us steps to adding fractions with different denominators, all right? So the first thing we do, we want to model the fractions. So we are going to use these counters to model the fractions. The second thing we do is we find multiples of the denominators. The third thing, determine the lowest common denominator. Fourth, we determine how many new sets of each fraction you need and make them. And the last thing is we combine the fraction sets. Alright? You think we could do it?
Yes.
Alright. So let's look at problem B here. What does the problem say? What is that first fraction?
1/4
Plus
2/3.
Good. So let's model these fractions first, alright? So the denominator tells us what? What does the denominator tell us?
The whole part.
So how many parts there are in the whole set, right? So how many parts are there in this whole set for this fraction?
4.
4, good. So we're going to count out 4 counters. 1, 2, 3, 4. And the numerator, what does the numerator tell us?
How many parts out of the whole?
Good. How many parts out of the whole are represented? So how many parts out of 4 are we going to represent there?
1.
1, good. So we're going to turn that one to its red side. So we have 1/4. Alright? So we have that one represented. Let's do the next fraction. What is that fraction?
2/3.
Good. And how many pieces are there in the whole set?
3.
3, good. So we're going to get 3, 1, 2, 3. And how many pieces are represented in that whole piece?
2.
2, good. So we're going to turn 2 of them over to the red side. So now we have 2/3, right? Good. Alright, so what's the next thing we do?
Find multiples of the denominators.
Find multiples of the denominators. Good. So let's start with the first fraction. What's the denominator in that fraction?
4.
4, good. So we're going to draw a 4 in our chart here. And when we're finding multiples, you can think of it as kind of multiplying. You know, multiple, multiplying, kind of sounds the same. So that's what we're going to do. So we're going to find the first 5 multiples of 4, okay? So what is 4 times 1?
4.
Good. What is 4 times 2?
8.
8. What's 4 times 3?
12.
12. Good. What is 4 times 4?
16.
Good. And what is 4 times 5?
20.
Good. And now let's work with the other denominator. What's our denominator for 2/3?
3.
3. Good. So we're going to do the same thing. Find the multiples for 3. So what is 3 times 1?
3.
3, good. 3 times 2?
6.
3 times 3?
9.
Good. 3 times 4?
12.
12, good. And 3 times 5?
15.
Awesome, good job. Alright, so what's the next thing after we have found the multiples?
Determine the lowest common denominator.
Good, so how do you think we do that?
We look at the chart and we try to see which ones have the same number.
Good, so we look for the first number that is the same for both rows, right?
Mm-hmm.
Alright, so what number do both of these rows have in common?
12.
12, good job. So let's circle those 12s. Alright, and now, after we have found the lowest common denominator, what's the fourth step?
We determine how many new sets of each fraction you need to make them.
Good, so to do that, we're going to see how many times we had to multiply to get the lowest common denominator, okay? So with 4, we had to multiply 1, 2, 3 times to get the 12, alright? How many times do we have to multiply with 3?
1, 2, 3, 4.
4 times, good. So how many sets of 1/4 are we going to have?
12. Make 3.
3, good. We're going to have 3 sets of 1/4. So let's make those 3 sets. We already have 1, so how many new sets do we need?
3.
So we already have 1. How many more do we need?
2.
2 more, good. So can you help me with this? So how many am I going to put out here?
2 more.
2 more sets, good. 2, 3, 4. There's another, and we need 1 more set. Good. So we have 3 sets. Alright, and how many times do we have to multiply the 3 to get the 12?
4.
4 times. So how many total sets are we going to need?
4.
4 sets. We already have 1. How many more sets do we need?
3.
Good. Can you make 3 more sets of that? Awesome, good job. Alright, so now the numbers that we circled on our chart represent the new denominator, okay? So that's going to be how many pieces we have in each set, alright?
Okay.
So we need to make sure that we have 12 in each of our sets. 12 total pieces, okay? So let's count the counters and see, make sure we have 12, alright? So count with me.
1, 2, 3, 4,
5, 6, 7, 8, 9, 10, 11, 12. Good, we have 12 there. Let's make sure we have 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good job. So what is the last thing that we do after we made all those new sets?
We combine the fraction sets.
Good, so we're going to combine the fraction sets into rows of 12, alright? So we're going to start with the red ones and see how far we get. So count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And do we need, is that enough? Do we need one more? We need one more?
No.
We have 11, but we need 12, right? So we need to put one more, right? It's going to be a yellow one because it's just going to be kind of a placeholder, okay? Alright, so we're going to put the other yellow ones down there too, but they're going to just be placeholders too.
Okay.
Alright. So when we combine the sets, our answer is going to be how many red ones we have in our new sets, okay? Alright, so how many do we have up here? How many red?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
And how many total are there?
12.
12, so 11 out of 12. Good, so 1/4 plus 2/3 equals 11 twelfths. Awesome, good job.
All right, so we just saw some modeling about how to add fractions with unlike denominators. On this next part of the video, you're going to see Stephen work with Natalia to do some guided practice. Now, she's going to do quite a bit of the writing, but you're going to see that he's there with her for every step of the entire process. So let's go ahead and watch what that looks like. Remember, I always want you to be cueing into how is the explicit instruction used, how are the multiple representations used, and what is the concise language that Stephen is using with Natalia.
So let's look at our next problem, Natalia. So what does this problem say?
2/3 plus 1/5
Equals good. So we have to figure out what 2/3 plus 1/5 is. All right. So what is the first thing we're going to do?
We're going to model the fractions.
All right. How do we do that?
We get the counters and we take 2 red ones and 1 yellow one.
All right. So 2 red and 1 yellow. And what fraction does this represent?
2/3.
2/3. All right, so there are 3 total pieces, right?
Yes.
And 2 are represented?
Mm-hmm.
Good. All right, how do we represent the next fraction?
We take 5 counters and have 1 red one.
1 red one. All right, 1, 2, 3, 4, 5, and turn 1 over to red?
Mm-hmm.
Good. All right, so we have both fractions modeled. And what's the next thing what we do?
We find the multiples of the denominator.
All right, how do we do that?
We take
So what's the denominator of the first fraction?
3.
3. All right, so let's write it on your chart. 3. All right. So how do we find the multiples of 3? Are we going to add or multiply?
Multiply.
Multiply, awesome. So what is 3 times 1?
3.
3, can you write it? 3 times 2?
6.
Good. 3 times 3?
9.
3 times 4?
12.
And 3 times 5?
2.
Awesome, good job. And what is the other denominator we have to find the multiples of?
5.
5, good. Awesome, so what is 5 times 1?
5.
Good.
10.
Good. Awesome, good job. Alright, so now that we found the multiples, what do we do?
We find the one that's common in both.
Good, so we find the least common, lowest common denominator. Alright, so which number in both of those sets do they have in common?
15.
15, good. So let's circle the 15s. Alright, so now we need to figure out how many sets of each fraction, right?
Mm-hmm.
Alright, so let's see. How many times do we have to multiply 3? 1.
1, 2, 3, 4, 5.
Good, so we have 5 sets of the 2/3, and let's figure out how many sets of the 1/5 we have. So let's see. 1, 2, 3. Good. How many sets of the 1/5?
5. I mean, 3.
3. Good. Alright, so let's make our sets of 2/3 first. So how many sets of the 2/3 are we going to make?
We are going to make 5.
5 sets. Good. So we already have 1 set. How many more sets do we need?
4.
4. Can you make those sets for me?
Mm-hmm.
Awesome, good job. Alright, so now we have our 5 sets of 2/3, and what do we do next?
Now we find our 3 sets of 1/5.
Good, so we already have 1 set of 1/5. How many more sets do we need?
2 more.
Good. Awesome, so we created our new sets, and what is the last thing we need to do?
We determine, combine the fractions.
We combine the fraction sets, good. So the number that we circled is going to be our new denominator, and so we're going to make rows of 15, okay? So we're going to use the red ones first, right? Okay. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we're going to use the yellow ones as placeholders, 14 and 15. Alright, so let's see. Alright, so to get our answer, let's see how many red ones we have representing. Alright, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 pieces out of how many?
15.
15. So what is our answer?
13, 15.
Good. Can you read it? Good. Can you read that whole number sentence for me, please?
2/3 plus 1/5 equals 13/15.
Awesome. Good job.
All right, so what you saw there was some really nice guided practice where Stephen was guiding Nataya through solving this problem. Now this last example that we're going to watch is going to be Nataya's independent practice. But do notice how Stephen isn't checked out. He's still there working with her every step of the way. Let's go ahead and watch that now.
So let's do one where you're doing it by yourself, okay?
Okay.
Alright, let's look at problem D. What does the problem D say?
1/2 plus 1/3 equals.
Alright, so what is the first thing you need to do in trying to figure out this problem?
Model the fraction.
Alright, how do you do that?
We take counters and we, for the first one, where 1/2, we use a red one to represent 1 out of the half. The 1 out of, yeah, half.
Alright, let me see it. Good. Alright, so how do you represent the next one?
We take one red counter out of 3 to represent the 1 out of 3.
Alright. Awesome, good job. Alright, so you've modeled the fractions. What next?
We find the multiples of the denominators.
Alright, good. Which denominator are you going to find the multiples of first?
1/2.
1/2, alright. Let's see. What is the denominator of 1/2?
2.
Good.
So 1 times 2 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. And 2 times 5 is 10.
Good. Awesome. Alright, and the other denominator is?
3.
Good.
3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15.
Awesome, good job. So you found the multiples, and what do you do after that?
We determine the lowest common denominator.
Good job. So what number in both of those sets are the same?
6.
Awesome, good job. So circle the sixes. Alright, so what do you do after that?
We determine how many new sets we need to find the fraction.
Alright, so how do you do that?
Well, we go to the, we jump to the numbers and see how many it takes to make how many sets.
Alright, so how many times did you multiply 2 to get 6?
1, 2, 3 times.
Good. So you need how many sets of 1/2?
3.
Good. So let's see how many sets you will need of 1/3 too. So how many times did you multiply 3?
1, 2, 2.
Good. So how many sets of 1/3?
2.
Good. So let's start with the 1/2. How many sets do you need?
3.
3. So let's see if you can make 3 sets of 1/2. Good. And how many sets of 1/3?
2.
2. Awesome. So we have one. Let's see if you can make 2 sets. Awesome. Good job. And what is the last thing you do?
Combine the fraction sets.
Alright. So how do you do that?
We take all of the red ones and put them together.
So the counters are going to be in sets of what?
They're going to be in sets.
What number did you circle?
6.
So we're going to be sets of 6, right? All right, so start with the red ones.
1, 2, 3, 4, 5. And we take a yellow one as a placeholder.
Good. And what do you do with the other yellow ones?
We take the yellow and just put them as placeholders as well.
Good. All right, so what is your answer?
So we have 1, 2, 3, 4, 5 red counters. Out of 6, it will be 5, 6.
Awesome, good job. All right, can you write your answer? All right, so what does that whole number sign say?
1/2 plus 1/3 equals 5, 6.
Awesome, good job.
All right, that was an awesome video where Stephen was teaching Natalia. And there, as I talked about as we went, but we saw the 3 parts of explicit instruction. We saw the modeling from Stephen. It was really focused on, he was showing Natalia how to add fractions with unlike denominators. Then we saw the guided practice where Natalia was doing a lot of the work, but Stephen was there asking her a lot of questions and helping her out, guiding her. And then this last thing we just saw was the independent practice where pretty much Natalia was able to solve this problem on her own. Now, just as we debriefed from the video around fraction concepts, I want to do a debrief about this video, and this one was really focused on procedures. But there were a few conceptual things that Stephen did talk about. And that was my comment before, that really anytime you are teaching mathematical procedures, those concepts always come into play. It's not always necessarily true that if you're focusing on concepts, you're also going to be teaching procedures. Many times if you're teaching concepts, it's very conceptual and very focused on that. But if we are teaching procedures, we might be focusing on concepts. And what were some of the concepts that Stephen emphasized? Well, first he was really emphasizing the idea about fractions. And so he talked about the concepts of a denominator and a numerator with Natalia. So those were important things to make sure that she understood those before he was ready to proceed with talking about adding those fractions with unlike denominators. The other thing that Stephen really focused on was understanding the models of fractions. And so he did a model where he used the set model, and I'll go ahead and color one of those in to kind of show a 1/4, but made sure that she had an understanding of the different models of fractions before getting to these procedures. Now, speaking of the procedures, Stephen, the nice thing that he did here is the first thing that he did was he introduced the steps. And so he had the steps written out on a little poster, and he read through those and introduced those to Natalia even before they got started. So it really gave her an idea of what they were going to do within the lesson. The second procedure that he really focused on here was the modeling of the fractions. So that's where this set model came into play. And then after modeling the fractions, he and Natalia worked on listing the multiples. So, and that goes all back to some of the stuff we've talked in previous modules about in terms of fluency with your multiplication facts. She had a really strong fluency with her multiplication facts, so it was super easy for her to list out the multiples. That's a procedure that she needed to have familiarity with before doing all the multiple work. The fourth thing that Stephen and Natalia focused on that was a procedure was changing the fractions to like denominators. I'll just put changing to like. I can't help myself. I have to write denominators here just so we remember what we're talking about. And then the final thing that procedure that they focused on was adding. So adding the fractions. I thought Stephen did an excellent job using explicit instruction, using the multiple representations, using concise language to set up this whole process, this procedure. There was one thing that he did that I would probably have done a little bit differently if I was the teacher of Natalia, and that involved the writing of the fractions. So in the first example, they were adding 1/4 plus 2/3, and they do all this excellent work for solving this problem, and then they come up with the answer, and it is 11/12. The one thing that I would have just encouraged Stephen to do is write the equivalent forms of the fractions when they figured them out, when they changed the fractions to like denominators. So that would have mean that 1/4 is equivalent to 3/12, and we added that to 8/12, which is equivalent to 2/3. And then here, this can emphasize, oh, I need to add the parts of the fraction. There are 11 parts. I'm always working with fractions that are with a denominator of 12. That denominator is divided into 12 equal parts.